For our demonstration and hands-on lab with vCenter High Availability, here, my friend, is what I propose. We already have the vCenter server appliance running on ESXi1. It is currently using the local data store on ESXi1, which doesn't bode well for things like vMotion. So here's what I propose we do. Let's do a storage vMotion off of the local data store on ESXi1, and let's place the files for the vCenter server appliance over on iSCSI-1, that data store. Another thing that we're going to need is some additional networking, so I added yet one more VM NIC to each of our ESXi hosts. ESXi1, 2, and 3, they all have another one, and they're all logically connected to this external network. And to facilitate that additional connection, what we're going to do is we're going to create an additional distributed switch. Now, the great news is we get to reinforce those concepts regarding the distributed switch that we've learned in previous nuggets. So in this lab, we're going to be implementing a distributed switch and including this additional uplink just for the benefit of supporting the vCenter high availability. What I also did was I added additional RAM to ESXi2 and ESXi3, so now they're all sitting at 20 gigabytes of RAM each. And I've also added a couple of additional LUNs over here as part of our iSCSI storage appliance. And those additional LUNs are LUN 3 and LUN 4, and they are each 200 gigabytes each. And so because they're sitting out here on the appliance just as LUNs, they're not data stores yet, we're also going to want to go ahead and create two new data stores based on LUN 3 and LUN 4 respectively, and I think we should go ahead and call those iSCSI-3 and iSCSI-4 for the data store names. And then when we run the wizard, we can go ahead and specify that for the vCenter server appliance, the active one, we want the active to run on ESXi1, and we can specify that we want the passive node to run on ESXi2, and the witness node can go ahead and run on ESXi3. And for data stores, we can go ahead and leave the active using iSCSI1, and for the passive, let's go ahead and use iSCSI3, and for the witness, we'll use iSCSI4. So for the creation of the distributed switch and the creation of the iSCSI data stores, which we've done previously, we're going to go through that fairly quickly in this nugget. But if you need reinforcement on any of those concepts, please feel free to go back to the earlier nuggets on those specific subjects. And regarding IP addresses on this HA network, for the active, let's use .111 on the 172.16.1 network. For the passive, let's use .112, and for the witness, we'll use .113. So we begin here at the vSphere web client, logged on as administrator at vSphere.local. And in order to optimize time, let's go ahead and do some of the longest tasks first, which include the migration of the vCenter server appliance, its storage, over to shared storage. So in the navigator pane, with the host and clusters currently selected, let's click on the vCenter server appliance right here. And currently we're on the data stores tab for that appliance. And it's currently using the data store local to ESXi1, the ESXi1 underscore data store. So to do the migration, we'll right click on the vCenter server appliance. From the menu, we'll go ahead and click on migrate right here. And then we'll choose the second radio button to change storage only. Click on next. And you know what? I want to pause that for a moment. I also want to get rid of the actual data store cluster. That's currently the home to our two iSCSI data stores. So in the upper right hand corner, we'll use the double right arrows to minimize and finish this work later. And let's click on the storage tab. And from here, let's just right click on data store cluster. And from the action menu, click on delete. We'll click on yes to confirm. And it doesn't actually delete the two data stores that were in that cluster. It just deletes the data store cluster. And that's also going to prevent storage DRS from making decisions on which data store we should go ahead and use. All right, so we'll go ahead and click back up here in work in progress up in the upper right, and then click on our task that we were working on. And let's go ahead and select iSCSI1 as the new home for the files for the vCenter server appliance. I'm also going to use the drop down and select thin provisioning. And in the lab environment, I'm always going to do that when possible just to save on disk space. And then we'll click on next. Here's our summary. We'll click on finish. And then we can go ahead and minimize the work in progress because we're done with that. And then if we click on recent tasks in the bottom left, it's now relocating that virtual machine, its storage, over to iSCSI-1. And that process, that may take about 10 to 15 minutes. So while that's in progress and cooking, let's do our other work. So we'll minimize recent tasks. And one of the things on our task list was to create a couple additional data stores based on two new LUNs that are available through our iSCSI target. So to do that, let's go ahead and right click on the Las Vegas Data Center. We'll hover over storage and we'll select new data store from the submenu. We'll put it in the Las Vegas data center. We'll click on Next. They're going to be VMFS, so we'll click on Next. And let's name this iSCSI_3_ data store. And then regarding the LUNs, we're going to use one of our ESXi hosts to get a visual on what LUNs are out there. And we have LUNs 3 and 4 that are available via iSCSI, so we'll choose LUN 3. So we'll go ahead and click on the row for LUN number 3. Also, notice over here the sector format. So the iSCSI is using 512E, that's the emulated. And there's also a locally connected LUN on ESXi2 that's using 512N, which means it really is a 512 sector size. It's not being emulated. Okay, so with the LUN 3 selected, we'll click on Next. We're going to use VMFS version 6. Click on Next. We're going to use all the available space. We'll click on Finish. So now it's creating that, and there it is. We'll go ahead and create another one based on LUN 4. We'll call it iSCSI_4. We'll right-click on the data center, hover over Storage, select New Data Store from the submenu, click on Next, accept VMFS, click on Next. We'll name this iSCSI_4_ data store. From the drop-down, we'll pick on a host to go ahead and get a visual on what LUNs still exist. We'll use ESXi2 again. There's LUN 4. We'll select it, click on Next. We'll accept the radio button for VMFS 6, click on Next. Take the entire space, and we'll click on Finish. So now that those two data stores exist, let's go ahead and make sure that each of the ESXi hosts know about them. And a quick way to do that is to click on the Host and Clusters tab right here. And then at the cluster level, we can simply right-click on the cluster, and then hover over Storage, and simply select Rescan Storage from the submenu. So we'll click on Rescan Storage, and I'm going to leave both of these options selected. Scan for new storage devices, and scan for new VMFS volumes. Now, if we were in the process of creating a new data store, and we said, hey, ESXi2, show us what LUNs exist, and it didn't see any, that would be a time when we would definitely want to do a scan for new storage devices. So in the lab, it'll just take a few seconds to run this on each of the ESXi hosts, so we'll go ahead and leave both of those checkboxes checked and click on OK. So we can click on Recent Tasks. Here it's showing us that the rescan for the host bus adapters and now for VMFS volumes is happening on ESXi1, and when that completes, it'll happen on ESXi2, and when that's done, it'll happen on ESXi3. And if we scroll down in this list, hey, look at that! Relocate virtual machine for the vCenter server appliance shows as complete. That's fantastic. So we'll minimize recent tasks, and next, let's create a new distributed switch for the sole purpose of supporting our high availability network for vCenter HA. So to do that, we're going to click on the networking icon here in the navigator pane, and we'll right-click on our Las Vegas data center, and from the drop-down, we'll hover over Distributed Switch, and from the submenu, we'll select New Distributed Switch. And let's name this vCenter HA D-Switch, and click on Next. All the ESXi hosts are currently running 6.5, so we'll leave that top radio button selected, and click on Next. We only need one uplink, that's all I added, so that's all we'll use. And for the port group associated with this distributed switch, let's name it vCenter HA D port group, and click on Next. So that way, when we run the wizard and it says, what network do you want to use for HA, we'll simply choose this port group name, which is associated with this distributed switch, which is also going to have an uplink that we'll configure here in just a moment as well. So with all that in place, we'll click on Finish, and here is our new switch right here. If we expand it, here's our port group, and the other group represents the uplinks associated with that distributed switch. So the problem with this distributed switch here, the one we just created, is that none of our ESXi hosts are using it yet. So let's invite them to the party. We can do that by right-clicking on the distributed switch, and from the menu selecting Add and Manage Hosts. And I'm going to choose the last radio button, which will give us all the options, Add Host and Manage Host Networking, and we'll click on Next. We'll click on the plus symbol to include our 3 ESXi hosts by selecting them all, clicking on OK. And then if we want to configure these individually, we can, or if they're all going to be identical regarding their uplinks and so forth, which they are, we can use this checkbox in the very bottom, put a check in it, and that way we can configure one and use the identical settings on the other two. So with that check in the checkbox, we'll click on Next. We'll choose ESXi1 as our standard, click on Next. And because we don't need to associate a VM kernel adapter with this new network from the ESXi host, I'm going to remove the check from the checkbox regarding Manage VM kernel adapters, and we're just going to manage physical adapters regarding this distributed switch. So with a check only in that top checkbox, we'll click on Next. Now the uplink I added was VMNIC 7, and so what we're going to do is going to scroll down, click on VMNIC 7, and with it highlighted, click on the icon for Assign Uplink right here. And we'll assign that uplink, VMNIC7, to uplink 1. So with it highlighted, we'll click on OK. And if we want to apply that same configuration to ESXi2 and ESXi3, down here, step 2, we can simply click on Apply to All, and it's going to apply to our other 2 hosts as well. So we'll click on Apply to All, and then we can scroll down this list to verify that it did what we expected it to do, and then click on Next. It's analyzing the impact because the uplinks that we chose were not associated with any existing switch, including not being used to reach any iSCSI destinations. It indicates that we have no impact expected as a result of these changes. We'll click on Next. And this summary says that we're adding 3 ESXi hosts that are going to use the distributed switch, and we're adding 1 VMNIC, 1 uplink from each of those ESXi hosts. And so we'll click on Finish, and ta-da! We now have our distributed switch right here with this port group and this uplink. And again, one of the beauties of a distributed switch is that it's consistent across all of our ESXi hosts, meaning each of our ESXi hosts are going to have this port group as part of being associated with this distributed switch. Another benefit of using a distributed switch is that we have additional opportunities to discover what we're physically connected to. Now, regarding the uplinks, if we're connected to a physical switch, what type of physical switch is that? Is it Cisco? Is it HP? Is it something else? And what port on that switch are we connected to? And there are some really slick techniques that we can use to discover who we're connected to. One of those is CDP, which stands for Cisco Discovery Protocol, which is supported on both the distributed switch as well as the standard switch. And with CDP, the switch port actually sends this little layer 2 message periodically that indicates things like, hey, this is the name of the switch, this is the type of switch, here's its capabilities, and here's the port that you're connected on. So our ESXi host can dynamically learn what it's physically connected to because of the CDP messages that are sent in. Now, CDP is Cisco proprietary. So if you're not connected to a Cisco switch, you're not going to be getting CDP. However, there is an industry standard method for advertising details about the port we're connected to, and that is Link Layer Discovery Protocol, LLDP. And that feature is only available on a distributed switch. So if we want to look at the properties of that, we could go ahead and edit right here using the edit icon, the properties of this distributed switch. And if we click on Advanced, one of the options is the Discovery Protocol, the default being Cisco Discovery Protocol, and the other being Link Layer Discovery Protocol. And then we can also specify whether we want to just listen, or if we want to just advertise, or if we want to do both, meaning learn via that protocol as well as advertise out to that physical switch via that protocol. All right, I'm going to click on Cancel, and let's take inventory. So regarding the vCenter server appliance, we migrated its storage over to shared storage on iSCSI 1. We created a couple new data stores. We created a distributed switch, as well as associated some uplinks for this high availability network. So our last step is to run the high availability wizard, and what we'll do is we'll specify that we want the active node to run on ESXi1, the passive node to run on ESXi2, and the witness to run on ESXi3. And regarding data stores, we'll use iSCSI1 for the active, and we'll use iSCSI3 for the passive, and we'll use iSCSI4 for the witness. So back at the vSphere client, let's go ahead and click on Host and Clusters over here on the top left. And let's select the vcsa.nuggetlab.com at the top of our hierarchy here on the navigator pane. And with it selected, we'll go ahead and click on Configure. And under the Settings section, we're going to click on vCenter HA for high availability for vCenter. Here it's showing us a beautiful diagram of what's about to happen with our active, our passive, and our witness. And this HA network that we're going to put them on is the 172.16.1 network. In the upper right-hand corner, we'll click on Configure to start the wizard. We have a couple of options, the basic or advanced. The advanced is going to make us do more work manually, so we're going to choose basic. But it does say that the prerequisite is to create a vCenter HA network, which we did a few minutes ago with the new distributed switch and its associated uplinks. So with the basic selected, let's click on Next. It wants the IPv4 address for the active node regarding the HA network. And we're going to use 172.16.1.111. And the subnet mask is 24 bits, and that's the way we spell 24 bits in dotted decimal. And the HA network down here, we'll click on Browse, and we'll select the vCenter HA dport group, which is associated with the vCenter HA distributed switch that we just created. And with that selected, we'll click on OK. So it shows up here, and then we'll click on Next. And now it's asking for the passive node and the witness node. What IP addresses do we want to use there? So for the passive, we want to use 172.16.1.112, and we'll hit tab a couple of times. And for the witness node, we'll use 172.16.1.113. And just to confirm, if we clicked right here on Show All IP Addresses, it'll show all the current IP addresses for the active node. So there's the IP address we assigned a moment ago for the HA network. There's the vCenter server's appliance address on our management network. There's its default gateway, and there's its DNS server. So that looks great. So we'll go ahead and close that. And with the IP addresses for the passive node and the witness node in place, we'll click on Next. So, so in this wizard, here's what it says we're about to do. It says the active node is going to be on ESXi1, the passive node is going to be on ESXi1, and the witness node is going to be on ESXi1. Now, what we want to do, of course, is separate those onto 3 different ESXi hosts. So we're going to have to do some editing to go ahead and make that happen. So what we'll do is we'll go ahead and we'll take the passive node section right here, and we'll click on Edit. And what we're looking at is we're looking at the details for the passive node right now. So we'll put this passive node in the logical folder called Critical VMs, and it's suggesting that folder because the active node, our current vCenter server appliance, is currently in that folder. So we can accept that, click on Next. Now it's asking us what host resource do you want to use for this passive node, and we want to use ESXi2 based on our plan, so we'll select ESXi2 and click Next. Now it's asking for the storage, and based on our plan, we want to use iSCSI3, that data store, for the storage. Let's also specify that we want to use thin provisioning for this passive node, and with the iSCSI3 data store selected, we'll click on Next. So here's summarizing the networks. Currently the management network is the VM network, which it is, and then the new HA network connection is going to be to the port group of vCenter HAD port group. Those look perfect. We'll click on Next. Here's our summary, and we'll click on Finish. We also want to make some changes for the witness node. We don't want it running on ESXi1. We want to spread the wealth. We also don't want the data store to be iSCSI1 for the witness. We want it to be iSCSI4. So we'll click on Edit regarding the witness node. And from the drop down, we'll go ahead and open up the Las Vegas Data Center. And we'll expand this to go ahead and put that also in the Critical VMs folder. Click on Next. We'll select ESXi3 as the host resource to use. We'll click on Next. For the data store, we're going to choose the iSCSI4 data store. From the drop down, we'll select Thin Provisioned, and we'll click on Next. There's the HA network that it's going to be connecting to as a witness, which is the same network that we used previously in the wizard, and we'll click on Next. Here's our summary, and we'll click on Finish. Now, before we actually do the entire deployment, we should take a moment and review the details here and also look at the compatibility warnings. So the active node will be on ESXi1 on iSCSI1. The passive node will be on ESXi2 and iSCSI3. And the witness node will be on ESXi3 and iSCSI4. That looks great. So let's take a look at the warnings. So if we click on the link for compatibility warnings, it says the new VMware vCenter Server Appliance Peer will be deployed on a data store with insufficient free space. Please select another data store with enough free space to deploy this VM. Well, So let's minimize that for a moment over here into Work in Progress. And let's just click on the storage icon for a moment and click on iSCSI3, which it was complaining about. Click on the Summary tab for iSCSI3. And holy schnikers, it's got like almost 200 gigs free. You know what? I think that's enough, especially if we're doing thin provisioning. So what we're going to do is take that warning with a grain of salt, and let's click back on Work in Progress. Launch the Configure vCenter HA to take us back where we were. And let's also take a look at the compatibility warnings for the witness node. So we'll click on compatibility warnings for that. It's also complaining about insufficient free space. You know what? I'm going to say it's going to be fine. And we'll click on Next to continue. So here's a summary of what is about to happen, assuming we have enough disk space. And we'll click on Finish. And we can also go ahead and click on the Work in Progress to get rid of that pane. And in the bottom left, if we click on Recent Tasks, it can go ahead and show us the progress. And it is done. So the entire process for the cloning and the powering on for both the passive and witness nodes, it started at 2:45 and it ended at 2:56. So from a clock perspective, the whole thing took about 11 minutes. So if we minimize the recent tasks, and then we go back to the host and clusters view right here, and select our cluster, cluster 1, by clicking on it here on the left-hand side, and then clicking VMs, we can take a look at all of the VMs inside of our cluster. And let's go ahead and expand this column just a little bit. And here we have the active, the passive, and the witness. running on ESXi 1, 2, and 3 respectively. And they've each been and they each have been provisioned a whole boatload of storage, but because we're doing thin provisioning, they're using considerably less. This would also explain why we got the warning that the storage would be inadequate, because it was needing about 240 gigs each, and the data stores we created, iSCSI 3 and iSCSI 4, were only 200 gigabytes each. So thank goodness for thin provisioning. And also, since we're right here, if we had to do a restore of our vCenter appliance, that's assuming we had a full backup that was ready to go. Before we do the restore, what we would do is go in and delete the witness and delete the peer to remove the high availability configuration, do our restore, and then once the restore is done, then go ahead and recreate the high availability. That same concept would also apply if we were going to issue a certificate. Now, we've done certificates in a previous nugget. However, now in a high availability environment, before placing a new certificate on the active vCenter server, we would delete the witness node, delete the standby node, then apply the new certificate, and then go ahead and recreate our high availability for vCenter. The general concept is, if we're going to make huge changes to the vCenter appliance, like certificates or restores, we'd want to tear down the passive and tear down the witness, do our work, and then once our active vCenter server is the way we want it, for example, with the new certificate or restored from a backup, then we would go back and recreate our vCenter high availability and add back in the passive and add back in the witness. In this nugget, we've done a step-by-step walkthrough of implementing vCenter high availability. And I encourage you, if you haven't done so already, to get that hands-on practice in the provided labs. So have some fun with that, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.